The oil and gas industry has always been a cyclic business, and it's really challenging in down cycles to continue to fund research. But it's vital to do so. It's technology that drives the energy business. It drives the oil and gas business, and it pulls it into the future. I'm Scott Tinker. I'm the director of the Bureau of Economic Geology at the University of Texas at Austin, and also the director of the Advanced Energy Consortium, as we lovingly call it, the AEC. Well, the AEC was created when I attended a conference well over a decade ago up in Colorado, and somebody in the meeting mentioned smart dust. And I thought, smart dust, that's pretty cool. What's that? And it was a space-based thinking that little teeny particles could have some kind of electronic intelligence. I thought, man, let's just grab some of those and shove them in an oil and gas field and get smart. So the AEC was formed to try to get small, smart things into rocks. The companies that came together to form the AEC knew that this was going to be research that was pre-competitive. And they said, rather than have a single company run that consortium, let's ask the University of Texas, the Bureau of Economic Geology, to run it for us and work with the industry and work with other academic institutions to create this very unique consortium of companies and academics. We knew we had to go out and find scientists and engineers that weren't necessarily working in the oil and gas space currently. This was a brand new area. We went out to universities around the world with a request for proposal and said, hey, are you interested? Well, the response was overwhelming. We got proposals from all around the country and all around the world to try to work in this new space. The nanotechnology world had in many ways the solution looking for a problem, and the oil and gas people had a major problem needing a solution.
We believe that application of nanotechnologies in reservoir management will be a game changer, improving productivity and also allowing major cost reductions in operations.
As the AEC began to transition from fundamental research to application, the industry came together and said we need to develop some practical applications or use cases, things that we can do to experiment in the lab and in the field, create prototypes and demonstrations, and finally go to a full-scale commercialization of these different kinds of products. So over the course of many, many months, industry and some key academics came together in several meetings and started with over 60 different kinds of possible uses, a big matrix of potential cases, and then began to narrow those down to the ones that really could fundamentally change what the industry was able to do today. Through time, industry has gotten better and better at characterizing the reservoir. We've worked on it hard, but the Advanced Energy Consortium is now to a point where we can significantly improve the ability to characterize, illuminate, and light up the reservoir. We can put small, smart sensors into that pore space and extract information that we've never gotten before. The AEC has successfully tested millimeter scale integrated temperature and pressure sensors at 125 degrees Celsius and 7,200 psi in brine and oil. The flexible microsystem platform will be expanded to include additional sensor technologies and improved electronics capabilities. These sensors are the smallest existing downhole capable systems. One of the great challenges, as we all know, is to get more oil and gas out of the fields, and water flooding and other chemical floods have been the strategy to do that. The AEC is creating materials and sensors now to put into water floods that will let us better understand where they're going, how they're moving, what they're accessing, and what they're missing as they stream and finger their way through these complicated rock systems. Magnetic nanoparticles are considered an excellent candidate for high-resolution monitoring of water floods using geophysical techniques. Our ability to image ferrofluids under flow has been proven in the lab setting. Hydraulic fractures are remarkable technology, making great advances, but they could be much better. Hydraulic fracturing cracks the rock in ways that have never been done before. And truly, we don't understand the extent of those hydraulic fracture networks whether or not they're all efficient, whether some are working and some aren't working. So the ability to go in and improve our understanding of that whole fracture network system would be a remarkable advance in technology.
We're tapping into at least 30 universities and research institutes around the world, and hopefully within the next year or two there's going to be some groundbreaking technology that's going to change the industry forever.
We want to facilitate and hand these technologies off to industry so that they can commercialize and compete fiercely to produce more oil and gas. It's a lot of fun. It's a great challenge anytime you're in a completely new research space to do that. But we're right in the heart of that now, and it's a remarkable opportunity for new companies to come join the AEC and hop in right at the critical time when they're going to be taking the technology and making money. We know that we need to continue to fund this basic research and the commercialization that's going to go on with nanoscience and nanomaterials. We know it's going to lift us into the future with the ability to extract oil and gas more efficiently and effectively from that. The most critical time to invest in that is right now.